Students, in this session, we are going to be covering probability distribution function, also known as PDF. So PDF are used anytime when you make predictions, anytime when you're in a business of making prediction, you will be using PDF. So for example, let's say you roll a dice, okay? You want to determine whether you're going to get 1, 2, 3, 4, or any one of these numbers. You are using PDF. You want to predict tomorrow is going to rain or not, whether it's going to snow. Well, you have to use PDF over there too. How about stock market? You know your stock market goes up and down. You also use PDF over there to determine how your stock is going to be tomorrow. Also, in artificial intelligence and machine learning, they use PDF. So every time when you get an email, you have a system that actually detects whether it's a spam or not a spam. Behind the scene, it is using PDF. Also, let's say you have an AI system. Okay, you feed this picture of a cat or a dog, and it determines what animal that is. It is using PDF. Artificial neural networks. Okay, they also use PDF. So they use something called softmax function. It actually uses PDF. So here we will try to understand your probability distribution function, why is it so important, and its types and some of its applications. So probability distribution function, it's a function. It describes how the probability of a random variables are distributed. In other words, it tells us how likely each outcome is. So there are a few terms I want to make sure that you understand. One is random variable, the other one is probability. So a random variable could be something. It could be anything whose outcome is uncertain. For example, let's say you roll a dice and you don't know whether you're going to get 1, 2, 3, what number. So that's your random variable. Let's say a test scores. You give an exam and you don't know what your score is going to be. That is your random variable. What about the temperature? You don't know whether tomorrow is going to be 90 degrees Celsius or 14 degrees Celsius. You don't know that. So that's your random variable. Generally, you use capital letter X to use to denote your random variable. Probability, on the other hand, is a chance. It's a chance of something happening, of an outcome happening. That's what your probability is. So let's understand this through an example. Let's say you roll a fair six-sided dice. When I say fair, that means every side is equally likely. Okay, this is a dice. It is not loaded. So here my random variable is going to be 1, 2, 3, 4, 5, 6 because these are my possible outcomes. The probability of each phase is 1 over 6, right? Because there are total 6 phases and the probability of getting any one of the phase is 1 over 6. So this is my outcome right here. 1, 2, 3, and these are my corresponding probabilities over here. So in this case, my PDF is going to be denoted with this expression. Probability of capital X equal to small x. By the way, anytime when you actually denote your instance of your probability, you use small x equal to 1 over 6, where my small x can be 1, 2, 3, 4, 5, or 6. So there are two types of probability distribution functions, discrete and continuous. So let's focus on discrete probability distribution function. Another name for discrete PD is probability mass function. So going forward, I'll be using the word PMF. And by the way, in literature, you're going to find this one to be more commonly used. So a PMF is a function. It is a function that gives you the probability of each possible discrete outcome. Okay, the key word is discrete outcome of a random variable. So an example of your discrete random variables would be like, for example, let's say you roll a dice. Okay, you roll a dice. The dice could be 1, 2, 3, 4, 5, 6. These are the numbers. So these are countables. Basically, another name for them is a countable. So this is a discrete. Another example would be coin. So let's say you toss a coin. It could be head or tail. Or let's say the number of students in your class. Well, the number of students is always going to be either 1, 2, 3, 4, 5, right? These are your discrete cases. Now, PMF is often written like this. Okay, this is how PMF generally is written, and this means that the probability that a random variable x, okay, random variable x takes the value x. That's what it means. Now, there are two main key points about regarding your PMF. Number one, it is non-negative. In other words, probability of something happening. Okay, this expression says that the probability of something happening is either zero or greater than zero. Either it's going to happen or not going to happen. Okay, that's what basically this is saying. In this case, sum of probabilities equal to 1. This basically says that when you take all the probabilities of every single possible outcomes and you add them all together, the answer is going to be 1. So if you go back, if you look at the previous example right here, if you calculate the probability of getting 1, okay, this is probability of getting 1 on the dice, probability of getting 2 on the dice. If I add all these numbers together, okay, I add all them numbers together, my answer is going to be 1. That's what it's saying. Okay, so let's understand discrete probability distribution, the PMF, through an example. So let's say we have an experiment. In that experiment, we roll a fair dice. And in this case, the random variable x is that an odd number shows up on your dice. That's your random variable x. So what is the PDF in this case? What is the PDF of x? Well, first you start with your x. What is the possible values of x in this case? It's going to be 1, 3, 5 because it's saying it's an odd number. These are my odd numbers. Then calculate the probability of your odd number. Well, probability of x equal to 1 is equal to 1 over 6. Probability of x equal to 3 is 1 over 6. And likewise for this 1 over 6. Okay, then so this is your probability distribution function right here. Now you can also depict this pictorially. You can also draw a little picture that will help you visualize this. So you type 1 over here, you write 1, you write 3 over here, you write 5. Now the probability of 1 is 1 over 6. So the height, this height is going to be 1 over 6. That's what this 1 over 6 is. Likewise, this, when I probability of getting x equal to 3 is 1 over 6. So the height, this height right here is 1 over 6. Likewise, the height of x equal to 5 is 1 over 6. So this is another way of representing graphically your probability distribution function, especially your PMF for your discrete case. Let's take a look at another example. So this is let's say you have a data set, and this data set contains the number of emails you have received each day for the last 7 days. So this is the data set that's given to you right here. Okay, and this one contains, let's look at this one. This one says the email 1 on day 1 was a spam. Okay, this says yes, spam. What about email 2? Spam, yes. Email 3, yes, spam. Email 4, nope, not a spam, and so on and so forth. So, assuming that your data, okay, assuming this data allows you for the calculation of your probability, okay, assuming that that you can actually calculate whether an email is a spam or not. Question is this: what is the probability mass function? Determine your PMF of x. So in this case, my x is a random variable. It indicates whether an email that you get, whether a new email you get, is it spam or not spam. So my x in this case is going to be spam, comma, no spam. So these are the two possible outcomes of my x. Now by looking at this data right here, by looking at this data, I can tell that the probability of x equal to spam is 4 over 7 because I got 4 cases of spam. You see that? 1, 2, 3, and 4. 4 cases of spam. So it's going to be 4 over 7. Okay, what about the probability of X no spam? Well, in this case, it's going to be 3 over 7 because I got this 1 right here, and then 2 right here, and then the third right there. So 1, 2, 3 is going to be 3 over spam. Then I just plot this over here right here. Now, this is just a visual representation. It just kind of helps me understand. In literature, you'll also find so a lot of authors, they actually use these pictures to help students understand. So in this case, x equal to spam. What is the probability of spam? It's going to be 4 over 7. So this height is 4 over 7. And likewise, this height right here is 3 over 7. Probability of no spam. Okay, now let's take a look at one last example, discrete probability distribution example. Suppose a product has been rated by a customer using discrete ratings. Okay, these are my discrete ratings right here. So let's look at this one. This one says that 10 people they gave 4 star. This one says 10 people again gave 4 star, and 40 people, okay, 40 people gave 1 star. Let x be my random variable that denotes the rating given to a product. Okay, so my x in this case could be any one of these values: 5 star, 4 star, 3 star, 2 star. That's my x. What is the PMF of x in this case? That's what they're asking you. So here, x is a random variable, and x can take any one of these values: 1, 2, 3, 4, 5. Okay, these basically indicates your ratings. So by looking at the data, we can see that the probability that you randomly pick a 1 star rating, okay, randomly pick a 1 star rating, which is p x equal to 1, would be equal to 40 divided by 100. Okay, 40, because how many people gave 1 star? Well, if you look over here, right here, 40 people gave 1 star. So it's going to be 40, numerator is 40, divided by the total. If you count all these numbers, okay, count all these numbers, your answer, your total is going to be 100. So it's going to be 40 divided by 100. So the answer is 0 0.4. Likewise, what is the probability that you pick up a rating, you randomly pick up a rating with 2 star? The answer is 0 0.25. Same thing, you take 25, okay, you take 25 and you divide 25 by the total number, and the answer is 0 0.25. Okay, likewise, I calculate this, this, and this. Now I'm plotting that over here. So this way it kind of like just gives me a little pictorial representation. So the probability Okay, this is my x equal to 1. So probability of 1 star right here is zero point 0.4 right here. Okay, zero point 0.4. This height is zero point 0.4. Likewise, probability of 2 star, okay, is 0. I want to say 0.25 right here. Okay, this is 0.25. And likewise, you can actually plot these 3 points over here. Okay, so now you know how to plot these points. Now you understand what a PMF is, how to find the PMF. So I showed you three examples. This was one example. This was another one. This one actually is an example from the email. And this example is from a rolling of a dice. Thank you.